Okay, so let's see if you have the math skills to solve this interesting little math word problem. Matter of fact, let me go and read you the problem. It is the following. The sun is at an angle so that a 20-foot tree casts a 35-foot shadow. What is the sun's elevation? Okay, so that is the problem. Feel free to use a calculator. And if you have the answer, put that into the comment section. I'll show you the correct answer in just 1 second. And then, of course, I'm going to walk through the solution to this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so this problem right here could be a bit confusing if you don't know what elevation means. That's effectively just how high is the sun in the sky. So if you're standing right here, you're an observer, and you're looking at the sun way up here, we're looking for this angle. This is basically the elevation of the sun at that particular moment in time. Okay, so let's go and take a look at the answer. Their answer is approximately 30 degrees. So if you got something like 29.7, 29.8, well, that tells me that in fact you did this problem right. And we have to celebrate by giving you a nice little happy face and A plus, a 100%, and multiple stars so you can brag to your friends and family that indeed you are a certified professional expert in the area of basic right angle trigonometry. Yes, you heard me correct. We're going to have to use a little bit of trigonometry here to solve this problem. And if you are not familiar with trigonometry, somebody might be saying, what are you talking about, Mr. YouTube Math Man? I'm not doing trigonometry. That's too advanced. No, no. Hold on 1 second. This is not that difficult. And if you ever wondered what these buttons are on your calculator, TAN, COS, and SIN, these are what we call trigonometric functions, and you're going to see why they are so important. And again, if you are not familiar with trigonometry, of course, I'm sure most of you have heard of trigonometry before, but if you're like scared of it, you're like, God, it's too complex, you're going to see that really this is not that difficult. Okay, so let's go ahead and get into the solution. And of course, we have our problem here. And you always want to use the rule of three when it comes to solving math word problems. That is, always read the problem at least 3 times. Make sure you understand all the information in the problem and what is the question. Now, of course, if you didn't understand what elevation means, I kind of cleared that up. By the way, for those of you that are students, let's say you're taking an exam or a test or any kind of situation, if you don't know what something means, always raise your hand and hope that your teacher will give you kind of a hint or clarify things, right? So you can't solve a problem unless you know what the words mean. Okay, so that's kind of the first thing here. Now, the second thing is that we want to kind of model the situation. That's always a good idea when you're dealing with a math word problem. Come up with some sort of visual way, if you can, to see the problem. And of course, here we can come up with a lovely sketch. So let's go and take a look at what I came up with. And of course, I get a great opportunity to use my basic art skills here. So here is the problem. Okay, we have this 20-foot tree and it's casting a 35-foot shadow. Now here is the sun, right? So the sun is kind of up here and its rays are kind of casting down like so. And of course it's creating this shadow. But this angle right here, this is the angle of elevation. So let's suppose you are standing right here and you're talking to your friend and they say, hey, I'm just curious, how high is the sun in the sky? Okay. Well, what they're asking is what is the angle of elevation? Okay. So, of course, you would say, well, it's this high in the sky. Well, what you're going to give them is this many degrees. And that is what the question is asking. Okay. How high is this sun up in the sky? I.e., what is the angle of elevation? Sounds like a fancy term, but that's basically what it means. Okay, so what we have here is a triangle situation. Now we have to make some assumptions. We have to just kind of assume that our tree is perfectly straight and perpendicular to the ground, and the ground is also nice and straight. So always when you're dealing with a math problem, never overcomplicate it. Okay, don't be like, well, what happens if there's a hill here and my tree's all off to the side? Well, no, just assume everything's nice and lovely and straight and perpendicular. Okay, so if you understand where I'm going here, then you'll be like, well, maybe instead of all this lovely artwork, we could just kind of distill this down and look at this triangle here, right, with all the information. And that's exactly what we're going to do. So we're going to distill this problem down to this problem. All right, so what we have here is a right triangle situation. This is very important. This is going to have a major impact on how we solve this problem because, again, this tree is perpendicular to the ground. So this is a 90-degree angle or a right triangle situation. Okay, so here is our tree. It's 20 foot, and then here is our shadow. It's 35 feet. And then, of course, this is the angle of elevation. And what we're looking for is this angle. But here is the thing. We only have this angle information, 90 degrees. We don't know what these other two angles are. Of course, if I knew this angle right here, I could solve for that angle pretty easily. So when you have a situation when you only have one angle in a triangle, and if you have one side or two sides of a right triangle, well, the only way to solve for these angles here is to use trigonometry. Now, I know it sounds kind of scary, but it's actually not too bad. Okay, now some of you might be thinking, well, it's a right triangle, I got some sides. Could I use the Pythagorean theorem? Well, certainly you could. And that's always one of the things that should always pop into your head when you're looking at a right triangle. But all this is going to do right here is get us this length. It's still not going to be enough information to get the angles. So remember, trigonometry, this word is basically the study of angles. It's the mathematics of angles. Okay, so let's go ahead and take a look at basic trigonometry right now. Okay, so before we can define some basic trigonometry, we need to understand the various sides of a right triangle. Okay, now what I'm going to be talking about here in just one second is something called trigonometric ratios. Trigonometric ratios. Effectively, what I'm going to be talking about is these things sine, cosine, and tangent. These nice, lovely buttons on our scientific calculator, but they're referred to as trigonometric ratios. Now, what is a ratio? In mathematics, a ratio is a fraction. Okay, so these are really trigonometric fractions. So we're going to be making some fractions, but before we can make these fractions, we have to understand what side is what in a right triangle. Okay, so let's take a look at this right triangle. This is a real right triangle. We have 3, 4, 5. And let's suppose I am looking at this triangle from this angle or this perspective, from this angle here. Okay, and I want to put some labels on these respective sides. So this is what we have to be able to identify. We have to be able to identify what side is has what name or what label. Okay, and there's three sides in a right triangle. Okay, when we're talking about basic trigonometry, and here they are. One side is the opposite side, the other side is the adjacent side, and one side is the hypotenuse. Okay, all right. So let's go ahead and define these. The longest side in a right triangle always, always, always is something called the hypotenuse. So in this particular right triangle here, 3, 4, 5, 5 would be the hypotenuse. Okay, so what about 3 and 4? Well, one of these, 3 is either going to be the opposite or adjacent. It all depends on where we're looking at the angle, what angle in the triangle we're using as a reference. So in other words, I'm looking at this angle here, okay? If I was looking at this angle here, the opposite and adjacent would change. So here's the way this works. So when you have your angle, okay, I'm looking at this angle here, the opposite side is, of course, the side that's opposite of the angle, okay? The side that's right next to the angle or adjacent is the adjacent side. So in this triangle here, the opposite side would be 3 and the adjacent side would be 4, and of course 5 is the hypotenuse. Okay, so again, when we're dealing with right triangles, you have to know how to label the opposite, the adjacent, and the hypotenuse. Okay, so now the fun part comes, and we get to use this phrase right here. This has been around forever, and it's a great way to learn basic trigonometry. And of course, this is a memory aid. Let me go and read it to you. This is SOHCAHTOA. SOHCAHTOA. And I know a lot of you are like, okay, Mr. YouTube Math, man, you're losing your mind. You're speaking a crazy another language. Well, no, hold on here. That's just a memory aid here. SOHCAHTOA. This stands for something. Okay, so what does it stand for? Let me go and tell you right now. All right, so this is sine. Okay, now if you were to spell it out, it's SINE, but the abbreviation is SIN. Okay, like sin. All right, but it's called sine. Okay, so remember I told you that we're talking about trigonometric ratios. So the sine of an angle is equal to the opposite over the hypotenuse. The opposite over the hypotenuse. So what does that mean? Well, if I go over here and I wanted to find the sine of this angle, I would all I would have to do is say, okay, the sine of this angle right here is the opposite, which it would be 3, okay, over the hypotenuse, which of course would be 5. Okay, so that would be 3/5. That's how this works. And again, this is a fraction or a trigonometric ratio. Okay, now what we do with this, the practical value of building these ratios, of course, you're going to see here in a second. But let's go ahead and finish up what the rest of this means. So that's what the sine is. SOHCAHTOA. So the sine is sine of an angle, okay, is going to be equal to the opposite over the hypotenuse. All right, how about the cosine? Okay, well, now that you see that this how this works, the cosine of an angle is going to be equal to the adjacent over the hypotenuse and the tangent of an angle. Matter of fact, let me just erase this here so we have enough room. The tangent of an angle is going to be equal to the opposite over the adjacent. So as long as we have these sides identified and our angle, we can find the sine, cosine, and tangent. Right. So this is going to be the first step in us being able to solve for the angle. Okay. So, but we can't do that unless you understand this SOHCAHTOA business. All right. So let's go ahead and take the next step, and that is to identify what do we have in our problem here. Well, if we look at our right triangle, we have, this is the angle that we want, okay? We have the adjacent side, which is 35, and we have the opposite side, which is 20, okay? So the information that we're dealing with is we have A and O. So we have to go back to our SOHCAHTOA here and be like, okay, which one of these has A and O, or O and A? Okay, this one has H. Well, I don't have H. I could find H, but the sine has the hypotenuse, cosine has the hypotenuse, but tangent has the O and the A. So let's use the tangent. Now again, I could find the hypotenuse, but it's not necessary. I have the opposite and I have the adjacent. So the tangent, by definition of an angle, is the opposite over the adjacent. Okay, so here, what we're going to do is use our actual information, 20 and 35. So the tangent of this angle is going to be equal to the opposite over the adjacent, which is 20 over 35. So we're trying to find this angle. Okay, now this is just a fancy variable called theta, but I'm going to replace it for, I want to replace this with the variable x. Okay, so we're going to solve for x, and we find what x is equal to. This is going to be the degrees. Now, of course, I already showed you the answer. It's pretty close to 30 degrees. So now this comes down to, how do we solve this trigonometric equation? Because this is where, you know, the real value of trigonometry comes into. And of course, we're going to need our lovely tangent button on our calculator to do that. All right, so let's go and take the next step, which of course is to listen to my tiny little commercial here. I have some pretty exciting news here. First thing is, if you haven't subscribed, please consider subscribing. That's a great way to show support for what I do. Been on YouTube for 10 plus years. I have over 2,000 videos. My mission is to teach as many people who need help in math or are interested in math and, you know, basically like my teaching style. I want to share all those years and decades of experience with people that can benefit from it. But the only way I can reach more people is by getting, you know, basically a lot of support, simple support. And, you know, when you subscribe, it tells that YouTube algorithm, hey, you know, people seem to like this guy, you know, pushes out my content. So I would definitely appreciate if you would do that. And if you're going to subscribe, you might as well hit that notification bell as well so you get my latest content. Okay, so I have a special announcement here. And I do this sale at most once a year, okay? Sometimes not even that, but I have a great offer for those of you out there that are interested in taking any one of my full curriculum math courses. Okay, now this particular offer is going to expire on this date right here, which is a week from when I'm posting this video. And basically, you can get 50% off these courses: pre-algebra, algebra, geometry, algebra 2, and pre-calculus. Now, we are talking about trigonometry, basic right angle trigonometry. You can, I teach that. You can find that in this course here. But if you want to learn like advanced trigonometry, then you need to check out my pre-calculus course. But this is my best instruction. What I do on YouTube is kind of like tutorials, and I kind of get into a lot of instruction, but it's kind of less formal, and I'm not covering everything. It's just these videos aren't designed to do that. It would just take too much. But if you are truly serious about wanting to really take a deep dive and learn, in depth and get a full comprehension of mathematics at any one of these particular levels, and you like my teaching style, well, this is my best work. And all these courses have taken me years to build, and in it you'll find various documents, quizzes, notes, etc., etc. But anyways, I'm going to leave the information to this sale, the discount code, and the links in the description below. So please take advantage of it because this will not come around for some time. Okay, so let's go ahead and take the next step and figure out how to solve for x. All right, so tangent of x, now x is some angle. I want you to think about this. The tangent of some angle is equal to 20 over 35, okay? Now let's take 20 divided by 35 in our calculator, and you're going to get 0.571428. Now this decimal goes on and on and on. I'm just going to kind of round it off right here. So the tangent of some angle x is this. Now a little note here. In your calculator, we have different modes that you can work with. One is degrees, the other one is radians. For those of you that have taken some trigonometry, your calculators are going to be in degree mode. In other words, if I say 40 degrees, that little circle up there is a degree symbol, okay? So we're talking about degrees. You want to work in degrees unless you're told to work in radians. If you don't know what a radian is, that's for a separate video, but you can learn all of that in my more advanced trigonometry stuff. But just know that your calculator can switch between degrees and radians. Now, this happens all the time. If you know how to work with radians, what happens is students switch their calculators to radians and then they forget to switch back to degrees, and then they get a lot of problems wrong on their test. They do everything right, but their calculator is in radian mode when it should be in degree mode. Anyways, don't mess with that mode, okay, unless you have a reason. But I'm just telling you, be aware that your calculator is going to be in degree mode. So what we're asking here, or what we're trying to find, is what angle in degrees, okay, has a tangent of 0.571428. Okay, so what we need to do is go to our tangent button, TAN on our calculator, and usually there's like a second button or some sort of, now you can shift. You can see what you're looking for is this, TAN to like a -1. Okay, this is the arc tangent, and this is what we need in order to solve this problem. You're looking for the TAN to the -1. And of course, that is going to be like the second function of that tangent button, that tangent function on your calculator. And this is awesome. Okay, now I'm going to show you the correct answer, and I'm going to revisit this in just 1 second. So let's go ahead and figure this thing out. So what this tangent, arc tangent button function will do, so you're going to hit the second key, you're going to hit this key, and then it's going to say, all right, type in some information. So what this is going to tell us is going to say, this button is basically going to give you the angle of that has this tangent, okay? So if like, hey, you know what, Mr. Calculator or Mrs. Calculator, what angle has a tangent of 0.571428, okay? Well, if you go tangent -1 and you plug that in, it's going to give you the answer, okay? Now, I'm going to round off again here, and that's going to be approximately 29.74 degrees. So I just kind of round up to approximately 30 degrees. So that is how you use a tangent and arc tangent. All right, now just an interesting little comment here. Calculators, okay, been around, personal calculators, even pretty sure, I think they're on a commercial setting, like in early 1970s, I want to say. Some of you probably actually know the answers. It was definitely the early 70s, but a basic calculator, these things would cost thousands of dollars. I know a lot of you can't believe that, but the reason why I'm talking about that is if some of you went to school in the 60s or 50s or in the 70s, calculators start becoming more and more important. And of course, these were basic calculators, and eventually, these calculators would have tangent functions and all kinds of other important functions needed in mathematics. But it wasn't until like, let's say in the 80s when I went to high school where people were really using calculators. But during that time, it was quite common for students to have to look a decimal up like this. They would have to go into the back of their trigonometry book. Okay, so I'm just kind of sketching out a poor little book here. So this would be trigonometry, and I can't even spell here. Let me just fix up my book. This is a terrible sketch. I'm usually a little bit better than this. All right, so here's trigonometry. So you'd have to go into the back of the book, and there would be all sorts of tables and you'd actually look these things up. So the only reason I bring that up is for some of you out there that are learning this, it was much more interesting to do trigonometry back in the good old days. Not only that, you'd have to use tables to find values of trigonometric functions. You would also have to use a slide rule. Okay, now I didn't use a slide rule. Maybe some of you used a slide rule, but if you don't know what that is, it's basically a ruler with a little thing that slides, and there's all kinds of little values on the side. These things are awesome. Basically, these were manual calculators, but they were very sophisticated and very, very good. And engineers and all different scientists, mathematicians use these things. Somewhere, I think maybe the transition started taking place maybe in the mid 70s, I want to say, when those calculators started becoming more available. Okay, but anyways, you have to really appreciate the technology that you have. These scientific calculators, graphing calculators are tremendously powerful. They're basically supercomputers, at least from a mathematical standpoint. So you could do a ton of them, but it also creates another problem where people don't understand how to use their calculator. And I'm going off on a couple tangents here because some of you that are students, make sure you know how to use your calculators, okay? That is important, but that is a separate discussion, and maybe that would make a nice YouTube video. All right, so let's go and wrap this up. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.